Hi everyone. So from the last section, you may be wondering, what is all that good for, right? What can I do with solving systems of equations? And ultimately, math comes down to solving problems, right? And so these are the word problems that I know a lot of people have trouble with. So I'm going to try to talk you through it. But this is where we're going to use what we learned last time, solving systems of equations. Okay, so let's get to our first example. It says Tanya bought 3 adult tickets and 1 children's ticket to a movie for $32. Lee bought 2 adult tickets and 5 children's tickets for $49.50. Find the cost of 1 adult ticket and the cost of 1 children's ticket. Okay. Right. So where do we even start? Right? This seems like a very difficult problem, at least at first. And so, right, where do we begin? So again, step by step, the first thing we should always look for in these problems is make sure you understand what the problem says and what it's asking. So read the problem carefully and try to determine what is it asking for. So determine the actual question here. What are they looking for, right? They're looking for the cost, right, of 1 adult ticket and the cost of 1 children's ticket for whatever movie this is, right? So, so this is going to be what we're looking for. We're looking for the cost, right? So we need to find the cost, right, of each adult ticket and each children's ticket. Okay. Right. Now, in other problems, of course, this might not be as obvious, or it might not be as easy to figure out what they're looking for. Again, just read the question carefully, and if it helps, draw a picture. In this case, I'm not going to draw anything, but in other examples, it might be helpful to draw a picture, or to make a table. Right. And by table, I mean, like a matrix, right? Sometimes it's, 2 by 3, 3 by 2, but something like this. And just to try to fill in all the information that we have and all the information that we're given. Okay. The important thing here is once you determine what the question is and what you're looking for, we need to essentially label what we're looking for, right? Right, so we need to declare our variables. Right. So in other words, let's just assign a letter to each thing that we're looking for, right? So what are we looking for? The cost of the adult tickets, right? So we can use C for cost, but notice that we need the cost of the children's tickets too. So we don't want to use the same letter for both. Right, so since it's an adult ticket, why don't we let A be the cost of each adult ticket. I hope that's legible. Right, so A for adult, right, and then we can use C for children's tickets, right? So let C be the cost of each children's ticket. Okay. So that's the first thing you want to do, right? Make sure you understand the question, figure out what it's asking for, and then declare your variables, right? And you don't have to use A and C. You can use X and Y are good letters for variables. But in some cases, I try to let the letters represent what they're looking for here, right? Okay. So what's the second step? What's the next thing we want to do here? Well, so this is probably the most difficult part, right? What we need to do is translate these statements, right, in words and write them as equations, right? So translate the words into equations. Right? And there's various tricks for doing this. Again, making a table sometimes helps here. And I'm going to run out of space, but let me see if I can bring this down here. So here's my little table. Yep. Okay, so 2 rows and 3 columns. That's going to be pretty much uniform for most of these types of questions. Most of these word problems, this is the table you want to make here. Okay, so let's start with the columns. For the columns, we have the cost of the adult tickets, I can abbreviate, right? And then the cost of the children's tickets. Right. And then, of course, when you add them up, you get the total cost for all the tickets, right? So we're going to add cost of all the adult tickets and all the children's tickets, and then that's going to equal the total cost. Got it? Right, so what about the rows? Well, the rows are the 2 statements here, right? And the first has Tanya buying a certain number of tickets. So this will be for Tanya. And then Lee is the other one. Okay, so Tanya bought 3 adult tickets. So 3 adult tickets, right? And each one costs how many dollars? Well, that's the question, right? A is the cost of each adult ticket. We don't know how much that is, right? If it's, let's say, $1 each, then it would be $3, right? Because 3 tickets times $1 each is $3, right? If each adult ticket was $8, then 3 times 8 would be $24, right? So A just represents the unknown amount of money that we have to spend for each ticket. And because there are 3 tickets, right, we multiply 3 times A. Does that make sense? So 3 times A is the cost for 3 adult tickets. Right? And then 1 children ticket. So that's going to be 1 times C. Right? So when you add all these up, right, you get 3A. Well, here, let's do that later. The total cost for all 4 tickets was $32, right? So that's the total. That's the total. So that's 32. Okay, so far? Right. So for Lee, there were 2 adult tickets. 2 adult tickets and 5 children's tickets. So 5 times C. And the total there was $49.5, right? $49.50 or $49.5, right? All right, so this is just organizing all the information that they have up here in the question, and we're just organizing it in this little table here. Okay, so if you can do that, then the translating part is almost automatic here. So remember, we want to translate all these words up here in the question to equations. Well, remember, it's the cost of the adult tickets plus the cost of the children's tickets equals the total cost. So guess what we do? We're just going to add the first column, that's 3A, plus the second column, that's 1 times C, and that's going to equal the third column, 32. Makes sense? And then do the same thing for the second row. In the first column, we have 2 times A, right? In the second column, we have 5 times C, and in the third column, we have 49.5. So those are the equations, right? So this is something you could have seen in the last section. This is a system of 2 equations. Okay, so what do you think we're going to do with this system? This is step 3 now. Remember, we're looking for the cost of each adult ticket. We're looking for A, and we're looking for C. So in order to find those, we have to solve this system. So that's step 3. Solve the system of equations. Okay. So this might look a little bit different here because we're not using x and y like usual. We're using A and C, right? So we're looking for an ordered pair, A and C, right, instead of, say, x and y. But it's the same idea, right? So the system of equations is 3A plus C is equal to 32. And the second equation is 2A plus 5C is equal to 49.5. Okay, so one other difference, of course, is that I think in the previous examples we didn't have any decimals, but we had fractions. And of course, if you don't like decimals, you can always convert this to a fraction. This is just 99 over 2. But I think most of you are comfortable enough with decimals, so I'll leave it as 49.5 if you like. Right. And one thing you can do, just like with fractions, you can get rid of the decimals if you want by just multiplying both sides by whatever it takes to get rid of the decimal. In this case, we can multiply both sides by 2. Right. And then that becomes 4 times A plus 10 times C is equal to, well, 49.5 times 2 is 99. So everyone see where I get that, right? 2 times 2A is 4A. 2 times 5C is 10C. And then 2 times 49.5 is 99. Right? And the first equation, there's no decimal, so we can certainly leave that alone. Right? And now we have a system without decimals or fractions. Right? So that might help. Okay, so right, you can solve this system virtually any way you want. Right? You can use the method of substitution if you find that to be easier. But since we focused on the method of addition or elimination, I'm gonna use the method of addition here. So in the method of addition, we have to pick which variable we want to eliminate. Do we want to eliminate A or do we want to eliminate C? Well, you could do it either way, right? If you want to eliminate A, you multiply the first equation by 4 and the second equation by -3, right? So you'll get 12A and -12A, and those would cancel. Right? So nothing wrong with that. On the other hand, since we have 10 times C for the second equation, I just need a -10C in the first equation. So just multiply both sides by -10. Make sense? And that becomes what? That becomes -30 times A minus 10 times C is equal to -320. So everyone okay so far? For the bottom equation, we don't have to do anything to that. I'm going to leave it as 4 times A plus 10 times C is equal to 99. Right? So now when we add the two equations together, we should eliminate C here, right? What we get is negative 30A plus 40A is negative 26 times A, right? Plus negative 10 plus 10 is 0, so 0 times C. And that's going to equal negative 320 plus 99. So get out my calculator here, and I think I get negative 221. Just making sure. Yep. Yeah, wait a minute. I don't think I did this right. So negative 320 plus 99. Yeah, negative 221, just making sure. Right. So we've eliminated C, and now we can just solve for A, right? We get negative 26 times A is equal to negative 221. So just divide both sides by negative 26. And when you do that, we get A. Right? So the negative 26 divided by negative 26 is 1. 1 times A is A. And the negative 221 divided by negative 26 is 8.5, 8.5. Right? So we're halfway done. We have A. What is A? A is the cost of each adult ticket. So each adult ticket costs 8.5 what? Well, these were all in dollars, right? So $8.5. Okay. Makes sense. So we need one more thing. We need to find the cost for each children's ticket. So we need to find C. But now that we know A, we take any equation here and we can solve for C. I'm going to take the first equation, this one up here, right? 3 times A plus C equals 32. Let me just copy that down here. And now we know what A is, so replace A with 8.5. And now we can solve for C. Right, so 3 times 8.5, 25.5. Let me just double check. Yep. And so now we just have to subtract 25.5 from both sides. Right. Why am I subtracting? That's the opposite of adding. Right. Here we were multiplying negative 26 times A. So the opposite of multiplying is dividing. Right. But here we're adding 25.5 plus C. So the opposite of adding 25.5 is subtracting 25.5, right? And so 32 minus 25.5 is 6.5. So C is 6.5. 6.5 what? $6.5. So we can make it $6.50, right? And I think that answers the question, right? So step 4 is to answer the question. Right? So let's see, way up here. Find the cost of one adult ticket. The cost of one adult ticket is $8.50. I was going to say, yeah, so the cost of one adult ticket is $8.50, right? So that was the first question. The second question is find the cost of one children's ticket. So the cost of one children's ticket is $6. Oops, a little sloppy there. There we go, $6.50. And that answers the question, right? So we're done. Okay, so let's just go back and make sure, right, we can figure this out here. So the first thing you do, read the question carefully, make sure you figure out what is it asking for, right? So it's asking us to find the cost of one adult ticket and the cost of one children's ticket. So each adult ticket and each children's ticket, right? So I labeled those as A and C, A for adults, C for children. And so in step 2, we want to translate the question here, all these statements, into equations, right? And that's usually the hardest part, right? I made it look easy, I know, but the idea is to make a table, right? If you find it helpful, and based on the table, each of these rows just corresponds to an equation, right? In this case, it's this plus this equals this, right? And in the bottom equation, it's this plus this equals this. So once you have the equations, your third step is to solve that system of equations. And again, I use the method of addition. You could just as easily use the method of substitution, right? I would not choose the method of graphing. Again, I did graph a couple of these lines. It was a little sloppy, but that is a third way you could solve a system of equations, by graphing. So we're not going to do that here. It's going to be pretty sloppy and it might not give us exactly what we're looking for. So either the addition method, aka the elimination method, or the substitution method would have worked. Okay, so I hope this helps, right? So based on this problem, let's try a similar one. Okay, so second example, and again, if I were you, I would try this one yourself, right? It's very similar to the previous example, and just go through it step by step. Okay, so let's see how it's done. So the first thing is make sure you read the question carefully. So Kelly sells 62 shares of stock she owns for a total of $433. If the stock was in 2 different companies, one selling at $6.50 per share, the other selling at $7.25 per share, how many shares of stock of each company did she sell? Right. So the question is how many shares of stock, right? But there's 2 companies, right? And we don't know what they are exactly, but we can label them, right? So there's company 1 has $6.50 per share, right? And we're looking for the number of shares, right? So let's call that X, right? So let X be the number of shares. Everyone read this. I know this is a little bit sloppy here. The number of shares of company 1. Okay, so for the other company was $7.25 per share. Right. So we'll call that Y. Let Y be the number of shares of company Y, company 2, right? Right. Okay. So far so good. Right. So step 2. Now we have to translate all this into equations. So again, if I were you, I would make a table. Comes in very handy. All right. And so let's start with the columns, right? We have the cost per share, right, times the number of shares, and this will be the total cost, right? Right. So notice this is times now, not adding, right? And we have two different companies, right? Company 1, Company 2. Right. And what are we given? We're given that for Company 1, the cost per share is $6.50. You can just do 6.5 if you like. And the number of shares, well, we don't know that. That's going to be X, right? So if we had 2 shares, then 6.5 times 2 would be $13, right? If it was 3 shares, it would be $19.50, I think, right? So if it's X shares, it's just 6.5 times X, right? Okay. Company 2, right, was $7.20. Oh, shoot, little mistake there. I don't know where I got 750 from. It's 725. So let me erase that and put in the correct number. Boy, I almost got it wrong because of that, right? So yes, it says in the problem that it's $7.25 per share for the second company, not 750. Okay, good. All right, so the cost per share is 7.25, right? Times the number of shares. Again, we don't know what that is, so we're calling that Y. And so the total cost is 7.25 times Y, right? So, right? So we already have the number of shares here, right? So this is, number of shares is X, number of shares is Y. Those are what we're looking for. And now we have the total cost, right? The total cost for all the shares for both companies was what? It was $433. So when you add Company 1 plus Company 2, you should get $433, right? So that'll be our first equation. So maybe I set up the table a little bit differently than I did last time. And so if you find that confusing, we can make another table here. And so for the number of shares, X plus Y, the number of shares that was also given, right? That was 62 shares. So X plus Y would be 62. So those are our two equations. Right. So probably what I should have done was this. Right. So we have Company 1, Company 2, and then the total. And in the first example here, we have yeah, so I'm sorry, for the first row, we're just going to have the number of shares. Right. And in the second row, we'll have the cost, right, of the shares, of stock. Right. So the number of shares for Company 1 is X, number of shares for Company 2 is Y, and the total number was 62. Again, that was given in the problem, right? You can fill that in all there. And the cost of the shares, so, right, so we already have $6.50 per share times the number of shares. That's going to be 6.5 times X, right? And then for Company 2, it was 7.25 times Y. And then the total cost, $433. Okay, so this will give us our equations, right? X plus Y is 62. 6.5 times X plus 7.25 times Y is 433. So those are our equations. Everyone okay so far? Yeah, so I didn't really need this first table here. I just did that to organize the information. It's really the second table that's more comparable to the table we used in the first example. All right, so we're on to step 3 now. Step 3 is to solve the system of equations. And, well, here's the system again, right? So we're looking for x and y, as usual. And we can use any method you want. You can use substitution. You can use the addition method. So I'll stick with the addition method. But it's pretty reasonable to use substitution here as well. Okay, and right, so we don't have to do this, but since the first equation doesn't have any fractions or decimals, the second equation does. I'm going to multiply the second equation by what? Well, if you want to get rid of all the decimals, right, you can always multiply by 100 because, right, this is 1/100th of a dollar. 1 penny is, right, $0.01. So that'll get rid of all the decimals, of course. But we can, so if you want to use a smaller number, notice that this is 0.25. That's just 1/4 of a dollar. So we only need to multiply by 4 to get rid of all the decimals here. Right? Again, if you want to multiply by 100, that's fine. You're just going to get slightly bigger numbers. Okay, so 4 times 6.5, I think is 26. Right? And then 4 times 7.25 is 29. Oops, so plus 29y. I'm just double checking there. Yep. And then 4 times 433. So that's the right side of the equation. 4 times 433 is 1,732. Okay. Right. So again, that's just to get rid of the decimals. And now we can eliminate x, we can eliminate y. I think x is pretty easy. We just need a negative 26 times x, right? So negative 26 times y, and then negative 26 times 62. So negative 26x, negative 26y equals, so 62 times negative 26 is negative 1,612. And we can leave the bottom equation alone because we're trying to eliminate x here. Right? So just add the two equations. You get 0x plus 3y equals, now I need a calculator for this. So 1732 minus 1,612, I get 120. And so we're almost done, right? 3 times y is 120. The opposite of multiplying by 3 is, well, dividing by 3. And 120 divided by 3 is 40. Okay. So we're halfway done. Now that we have y, we can find x. So you can use either one of these equations. I'm looking at the first one as probably easier here, right? If x plus y is equal to 62, and now we know what y is 40, we can solve for x, right? Take away 40 from both sides, and 62 minus 40 is 22. So x has to be 22. Right. But 22 what? $22? No, right? So let x be the number of shares, right? So we're talking about 22 shares of stock. That's $6.50 per share. That's company 1. And then 40 shares, right, that was $7.25 per share. So to answer the question, right, don't forget that's step 4. So the first question was, let's see, how many shares of each stock? So how many shares of each stock from company 1? So 22, right? So there were, well, okay, we can say that, but right. So Kelly sold 22 shares of company 1 at $6.50 a share. Right. And 40 shares of company 2 at $7.25 per share. And that should answer the question. Does that make sense? So again, step 1, declare your variables. So I did that here. I let X be the number of shares for the first company, the 650, and Y is the number of shares for the second company, that's the 725, right? Then you make a table, and I probably should have skipped this step here. I mean, if not, this is fine to write down both tables, but here I think it was more appropriate just to use the second table to get the equations. Right, so you fill in the table, you translate those to equations. Before I multiplied by the 4, right, I had this. Okay, and then you just solve that system of equations using the method of addition in most cases. In this case, the method of substitution would have worked as well. And then just answer the question. Right? Right. And it's a good idea to check, right? So there were 22 shares of the first company, 40 shares of the second company. When you add them up, you get 62 shares total. And that was the original question, right? Kelly sells 62 shares. So that part's correct. Now, what about the cost? Well, the price that she got was $433 total. Right. But that's a little tricky because that comes in 2 parts, right? 22 shares times $6.50 per share. So do the math, use your calculator. 22 times $6.50 is $143. Right? And that's just for company 1. And then for company 2, there were 40 shares times 725. So again, I'm going to use a calculator for that. No, I probably shouldn't need it. And I get $290. And that's just for company 2. So the total we got was, yep, $433 for both sets of shares, for both companies. Okay, so looks like it's correct. We checked it. Yeah, so I think I forgot to check the first example, but you know, at least I did it here. So maybe go back to example 1 and make sure it's correct. Okay. Okay, on to the next example. So, the question says this: as part of his retirement strategy, John plans to invest $200,000 in 2 different funds. He projects that the moderately high-risk investments should return over time about 9% per year, while the low-risk investments should return about 4% per year. If he wants to supplement a supplemental income of $12,000 a year, how should he divide his investments? Okay, well, let's go through this step by step. First question, or first step is to understand the question, right? So how should John divide the investments, right? So there's two different funds. There's the high risk fund. So there's the high risk fund, moderately high risk, right? Which gets 9% per year return on investment. Right? And then the low risk fund gets 4% per year. Right. Okay. So we want, let's see, $12,000. So John wants $12,000 per year. Right. So can we do this with the $200,000, right? So with a total of $200,000, right? So let's see, there's a lot of ways we can divide this $200,000 up into these two funds, right? We can just do half and half, right? 100,000 in the high risk fund and 100,000 in the low risk fund, right? But will that get us $12,000 a year? Probably not. After all, 9% of 100,000, I think is only $9,000, right? And 4% of 100,000 is $4,000. So that gets us, well, that gets us 13,000, which is, well, it's more than 12,000, but that's I guess that's not what we want. We want exactly 12,000. Okay, so it's not going to be an even split, right? It's not going to be 100,000 and 100,000. Right? It might be, I don't know, 150,000 and 50,000, right? But instead of guessing, let's give this a name, right? Let's call this X. This is going to be the amount of money invested at 9% interest, right? And then Y will be the amount of money invested at 4% interest, right, per year. Right, so we know X is not 100,000, Y is not 100,000. That gives us too much money, if there is such a thing. We want exactly 12,000, no more, no less, right? Okay. So that's what we're looking for. So to get the equations, we're just going to use a table. So that's step 2. Again, 2 rows, 3 columns. Let's try that again. Right. Okay, so 2 rows and 3 columns. So I would start with the columns. Let's start with the rows, right? For the rows, we have the amount of money, right, that we're investing. So the amount invested. Right. And I guess what we're looking for then is the return on investment. Right? So the second row will be the return on investment. Right? That's the 12,000 that we want per year. Right? And so for the columns, well, we have 2 different funds, right? We have the high risk fund. We have the low risk fund. And then when you add them all up, you get the total. Right? Right. So this is what they mean by diversifying your portfolio, right? Some you have high risk funds that might give you more money, but it's riskier and you might end up losing money. And then the low risk funds, well, you don't get as much as a return, but it's a more safer safer investment. You're not likely to lose much there, right? So that's the idea here, right? So the amount invested at high risk That's X dollars, right? And at low risk, it's Y dollars. And we know we have a total of $200,000 to invest. Right. So already looking ahead to step 3 here, right? The system of equations we're going to solve. The first equation is just that when we take x plus y, let me spread it out a little bit, we should get $200,000. Right. So my initial guess, if you remember, my guess was, 100,000 plus 100,000, but I tried that and that was not quite right. So good guess, but that wasn't going to cut it, right? So that's right. So that's why we're not guessing, we're actually getting equations that we have to solve here. All right, so the return on investment. So that's the percentage, right? This is 9%, or as a decimal, 0.09, right, times x. Right? After all, if we invested $1,000 at 9%, right, that would be $90. So 0.09 times x is the return that we get for the high-risk fund. And for the low-risk fund, we get 4%, or as a decimal, 0.04. Okay, so very important that you know how to convert percents to decimals. You just divide by 100, right? So 15%, for example, as a decimal would be 15 divided by 100, or 0.15. So yeah, make sure you convert your percentages to decimals, right? Okay. Anyways, so what are we looking for as a total? We're looking for $12,000, right, per year. So that's going to be, as an equation, 0.09 times x plus 0.04 times y is 12,000. So that is our system of equations. We just have to solve that system, right? And so that's step 3, right? We're going to solve this system of equations. So hopefully by now this is the easy part, right? The hard part is getting the equations. And again, that's just takes a lot of practice, right? Read the question carefully. Try to put all the information into a table like this. And if you can get the table right, usually the equations just follow from that. Okay, so we've been using the method of addition. I see no reason why to change that at this point. So let's use the method of addition again. And before we do that, though, let's multiply the bottom equation here. Well, I don't see anything obvious, because if we multiply by 25, we can make that a 1, but that's not going to make that that's not going to get rid of the decimals. So let's just multiply by 100 on both sides. Okay. So the first equation, we can leave that alone. That's just x plus y equals 200,000. Right? So 0.09 times 100 is just 9, so 9 times x, right, plus 4 times y is equal to 12,000 times 100, and that's 1,200,000, I think. Yep. Right, so we got rid of the decimals. Now just multiply by, I don't know, -9. That'll cancel the x's. Or, if you want to cancel the y's, multiply by -4. Again, on both sides. So that equation now becomes -4x, right, minus 4y equals -800,000. And in fact, I'm not going to copy down the second equation because I think we can just add them up as they are here. So add these two equations together, and we get 9x plus -4x is 5x, right? 4y minus 4y is 0y. Right? That's why we multiplied by -4, right? -4 plus 4 is 0. We canceled the y's. We got rid of the y. We eliminated y. Right? All right, so 0 times y is 0, right? And then 1.2 million minus 800,000, I think is 400,000. So now we can solve for x just by dividing by 5 on both sides. Right, so 5 divided by 5 is 1. So we get x equals 80,000. And this is the amount of money, right? This is in dollars. So $80,000. Oops. $80,000 for X. X is the high risk fund, right? So we'll come back to that, but just as a reminder, this is the high risk fund. And then for the low risk funds, we're looking for Y. But when you look at the first equation, X plus Y equals 200,000. And now that we know that X is 80,000, we can find Y just by subtracting the 80,000 on both sides. So Y equals what? 200 minus 80 is 120. $120,000, right? $1,000. There we go. Great. So I think that does it. So how should he divide his investments? Well, so to answer the question, this is step 4. So we're just going to answer the question. John should invest $80,000 in the high-risk fund. Right, that's the 9% rate of return. And $120,000 in the low-risk fund. I think these are, yep. And that was the one at 4% interest, or 4% rate of return. Right? So there's our answer. And this time I'll leave it to you to check. Right? Well, I'll let you check the easy part. 80,000 plus 120,000, of course, is 200,000. So that was easy. But do we get the 12,000, right? Because remember, it wasn't 100,000 each. It's a little bit more for the low risk than for the high risk. So if we take 80,000, right, times 0.09, I'm thinking it's 7,200. I need to check on my calculator. Yep, 7,200. And then 120,000 times 4% is 4,800. So when you add these up, you get exactly 12,000. So that's what we will make per year as a supplemental income. Again, for anyone lucky enough to have $200,000 to invest. Yes, so that would be nice. So that's how it works, right? So this is slightly different than the ones we did earlier, where we're looking for the number of shares or the number, the number of tickets, right? Here we're looking for the amount of money. So it's a slightly different problem from the previous examples, right? Okay, so I think we can try one more of these, and then we'll move on to more difficult problems. Okay, so a total of $24,000 is borrowed from 2 loans. One loan requires 6% interest, the other 8% interest. If the total interest of both loans is $1,540, find the amount borrowed in each loan. Okay, so that's the question. We need to find the amount, right, in dollars borrowed at 6% interest and the amount borrowed, I'll spell it out, the amount borrowed at 8% interest. Boy, that's a lot these days, but well, this could have been a very old question when interest rates were considerably higher. Okay, so that's what we're looking for. We're looking for two things, the amount borrowed at 6% interest and the amount borrowed at 8% interest, right? And the total amount borrowed, amount borrowed, right, we know is $24,000. So again, as a first guess, you might say, well, just split it up evenly, right? 12,000 each. So that's probably not the answer, right? But you can check that that doesn't give you, what are we looking for? The total interest, right, has to be $1,540. So if you do $12,000 each and you calculate the interest, I don't think you get $1,540. Although I could be wrong, but right. Well, let's see, right? So if it's 6% interest, right, we know that's 0.06 as a decimal. If we borrow $12,000 there, how much do we have to pay back in interest, right? So 12,000 times 0.06 is $720. So that's just the interest, right? And at 8% interest, if we also borrowed $12,000, right, that would be a total of $24,000. That's $960. So the total interest would be, looks like $1,480, which again is close, but it's not exactly $1,540. Okay, so once again, the answer is not to split it up evenly, right? There's a lot of ways of dividing up two loans into $24,000, right? It could be $10,000 plus $14,000. Right? It could be $1,000 plus $23,000, right? There's a lot of different ways, right? So let's let X be the amount borrowed at 6% interest. And let's let Y be the amount borrowed at 8% interest. Sorry to abbreviate all this time, and this is amount. All right. Okay, so that's what we're looking for. So make a table, right? We want the equations. We organize all the information in this table here, two rows, 3 columns, right? So for the rows, we have the amount borrowed, and we have the interests that we have to pay back. Right. Sorry about that. All right, so we have two different loans, right? One we have to pay 6% interest, and the other we have to pay 8% interest. Right, so this is the amount of interest we pay, right? And then we have the total. Right? So the amount borrowed at 6% interest, we're calling that X. The amount borrowed at 8% interest is Y. The total amount borrowed is 24,000. So the first equation, as you probably could have guessed, is that X plus Y has to be 24,000. And again, my guess was that x and y are the same, right? 12,000 plus 12,000 is 24,000. But we checked that, and that didn't add up to the interest we wanted, right? Okay. So the interests. Well, 6% as a decimal is 0.06. You multiply that by the amount of money you borrowed, and that's how much interest you have to pay back. Right? That's exactly what I did up here, right? We multiplied the interest rate as a decimal times the amount of money. And then that gives you the interest. The amount of money that we have to pay back. Got it? Right. Well, plus the original 24,000, plus the interest, right? Okay. Right, so the interest for 8% is 0.08 times y. And the total interest that was given in the problem, right? That's 1540. Yep, I'm just double checking, make sure that's right. The total interest for both loans together, here it is, $1,540, right? So that goes in the last column. And so now we add them up, 0.06 times x plus 0.08 times y has to be 1,540. Okay. So this is our system, 2 equations, 2 variables. Step 3, solve it. Right? Solve this system. Right? Using the addition method, as always. Although I've used the addition method every time, I'm going to show you the substitution method here, just to change it up a little bit. And some of you might prefer to do it this way. Right, that's fine. Keep in mind that, right, in a different problem where they give you the system here, they might tell you which method to use. But in these word problems, they never tell you what method to use. You just have to pick your favorite method. And, you know, since we focused on the addition method in the last section, you know, and I only did one substitution problem, I'll do one more, right? So here's how the substitution method works, right? You take your 2 equations. So I'm just going to copy them down again. Oh, before we do that, though, we can multiply both sides by 100 here, right? To get rid of the decimals. Right. So when we do that, we get 6x plus 8y equals, looks like 154,000. Yeah, I think in retrospect we could have multiplied by 50 to get smaller numbers, but this is fine. Okay, right, so yes, up until now, the standard method is to multiply, say, by -6, that cancels the +6, then you add the equations together, right? But to use substitution, we're going to solve for either x or y. So why don't we solve this for y, right? If we have x plus y equals 24,000, oops, too many zeros, 24,000, right? So to solve for y, just take away x from both sides. Subtract x. And that gives us y equals 24,000 minus x. Okay, so that's still the first equation, just solve for y. So now we're going to substitute for y this expression, 24,000 minus x, will be plugged into the second equation here. So instead of 6x plus 8 times y equals 154,000, we're going to trade y for 24,000 minus x. Why can we do that? Because it equals y, right? They're the same thing. This is an equation. These are equal. So whenever you see one, you can replace it with the other. Okay. So now we just solve this equation for x, right? There's no more y's. we're done with y, at least for now. We have 6x plus, so 8 times 24,000 is 192,000. Right, minus, don't forget to distribute, 8 times x equals 154,000. Okay, well, 6x minus 8x is negative 2x. Right. So we can subtract the 192,000 from both sides. Right. And if we do that, on the left side, we just get negative 2x, right, because this adds up to 0. And on the right side, we get a negative 38,000. Right. So negative 2x equals negative 38,000. So now just divide by negative 2. It looks like we get x is, again, it's a negative divided by negative, 19,000. 19,000 what? So that's the amount borrowed in dollars. So this is $19,000 that we're borrowing, right, at, I think 6% was for the first one, right? Okay, yeah, so notice that this is a negative divided by, it should be a positive number, right? For most of these problems here, you should not be getting negative answers. So if you ever get something like negative 19,000, you probably did something wrong. Because if you're borrowing negative $19,000, you're actually getting 19,000, right? You're borrowing a negative, so that means you're paying back 19,000. It's confusing when you see negative numbers here, right? Now, some problems, a negative amount is fine. In this case, this is the amount borrowed. We're not borrowing a negative amount, right? We're not paying them back. Okay. Well, look, we're almost done. Now we just have to find y. But remember, y was right here, 24,000 minus x. But if x is 19,000, 24,000 minus 19,000 is $5,000, right? Right, and this was at 8% interest. 8% interest. So now we just answer the question. This is step 4. Go back to the original question, find the amount borrowed in each loan. So the amount borrowed at 6% interest is $19,000. Right. And then the amount borrowed at 8% interest is $5,000. Okay, so that answers the question. Right. Now, on a typical test, I'm going to actually tell you what you need to know here, right? I'm going to write the amount borrowed at 6% interest is, and then you fill in the blank, right? So I'll write the amount borrowed at 8% interest, and again, you just fill in the blank. Okay, but of course, how do you get, right? So how do you get these blanks here? How do you get the answers? You do all this work, right? You have to write this down step by step. Step 1, declare your variables. If you don't declare your variables, if you don't tell me which one is x, which one is y, that's going to be confusing for me, and you're going to lose points for that. So be very careful, right? Make sure you're very clear which one is x, which one is y. Okay? So you have to declare your variables. Step 2, you should write down the table. If you're really not comfortable with the table, if you just rather write down the equations, okay. But I find it helpful to organize the information in a table, and then once you get the table right, the equations just pop right out of that, right? Okay, and then solving the system. So here I use substitution, but this would have been just as easy, if not easier, than to use the addition method. Okay, but you can see we would get the same answer either way. Right? So, yep, you solve for x, you solve for y, and then those numbers become your answers that you fill in the blank here. Right? Right. Now, so if I don't give you all this, you should write down very explicitly what the statement is. The amount borrowed at 6% interest is $19,000, and the amount borrowed at 8% interest is $5,000. Okay? So make sure you're very clear on what the answer is, right? Don't just leave it as, y equals 5,000, right? You want to write it in a statement. After all, the question was in the form of, statements, sentences, words, right? So you want to write the answer in the same way, right? Just to be clear. Right, so I hope this helps, right? So this is only part 1. We're going to do 2 other types of word problems that you get in this section, right? So one has to do, so the 4 types of problems, one of them has to do with cost. Those were examples 1 and 2. And the second has to do with interest, either if you're borrowing money or if you're investing money. I think example 3 was investing money, and you get a rate of return, right? And this example here, example 4, was borrowing money, and you have to pay back the interest, right? So 2 types of problems, right? The third type of problem, which we'll get to in the next video, I like to call these mixture problems. You're mixing 2 things together. And the fourth type of problem is what's called a motion problem, where things are moving. Right? So we'll talk about these 2 examples in the next video. But I didn't want to make this one too long, so we'll split this up into two separate parts.